this section concerns this bit of a project that Chris and I undertook off our own bat, really, in 2017, which is looking at the Itchen and Hamble, two sort of smallish rivers that discharge into Southampton water. And so they're similar in size, but not identical. So that there's actually, if you measure from the point where they discharge into Southampton water up to the tidal limit, where the tidal fluctuations cease, then there's about 10 kilometers different. The Itchen 23 and Hamble 33 kilometers. But why did we decide to try and plot the distribution of non-native species up and down these two estuaries? They appear amenable to a fairly low budget approach, being sort of quite small efforts, and have very nice distinct estuaries. But why do we wish to know about this at all? In short, why study estuaries? Well, estuaries are regions of intense commercial activity. Many cities, especially ports, are on estuaries, and estuaries are sheltered areas where there's a lot of industrial infrastructure, a lot of coming and going of boats, etc. Also a lot of aquaculture, and typically quite a lot of recreational boating. So they are real hotspots for non-native species coming and going. And it may be that well, it seems that they are well worth studying to get an idea of the dynamics of non-native species, a place to monitor for new arrivals, and a place which may need biosecurity provisions to prevent the departure of species from these sites and spreading to other places. So I hope that kind of seems like, whoops, fairly good reason to study estuaries. If we consider a sort of idealized estuary coming from something approaching the open sea, something approaching full salinity, and going all the way up, typically narrowing down to where tidal fluctuations are no longer evident at the tidal limit. Above here, there is fresh water flow, only the river flow. Now, so there's a gradient from the top of the screen to the bottom, from freshwater to the open sea, or something approaching the open sea. And so there's a gradient in saltiness, a gradient in salinity. Also, there are other gradients, perhaps a gradient in oxygen concentration, and almost certainly changes in the sediment load up and down the estuary. So there are these strong estuarine gradients, and we would surmise that species would arrange themselves along the estuarine gradient in terms of their occurrence, their zones of occurrence, in light of their environmental tolerances. And so one group of species, A, B, and C, are species which penetrate from the open sea, so they occur at full salinity or something close to it, and they then penetrate up the estuary, and we can envisage the different species penetrate to differing degrees. So A just goes a short distance up the estuary, C goes halfway up, shall we say, something like that. Another category of species is a truly estuarine species which has its distribution within the estuary, and which may not go outside the estuary and may not go above the tidal limit. So the range is encompassed by the estuary. Species that live very near the top may be, again, true just estuarine species, or they may penetrate into above the tidal limit and into fresh water. And if they do that, then there are two views really. Either it's an estuarine species that penetrates freshwater, or a freshwater species that comes down into the estuary, and which we regard it as will depend to some extent on which animal group it belongs to, and to some extent it's arbitrary. Now, if you want to start a commercial enterprise of some sort at a site available in an estuary, it may be that your commercial enterprise is vulnerable in some way to some non-native species. It may be that you yourself constitute a threat by potentially exporting non-natives with movements of your product or whatever it is to other places. So for proper planning, you do need to know what non-native species are likely to be present at that point in the estuarine gradient. Okay, a converse or alternative scenario is if there is a species or a habitat that you wish to conserve, you wish to protect, and in which case you also need to know which non-native species deserve surveillance for possible arrival, or which non-native species are already there or are likely to already be there, which will impact your efforts to preserve or conserve this site. So the kind of distributional information shown by the bars on the right is useful in either scenario. So at this site, we need to worry about species C and D from our biosecurity planning point of view, and from potential economic impact or potential conservation impact. So what we did was we visited both of these estuaries essentially as pedestrians. So we accessed sites that we could by going down and getting access to the shore at low tide, or by going on jetties or floating pontoons, which, for instance, would be in marinas. And the number of sites we surveyed is shown there: 20 in the Itchen, 17 in the rather longer Hamble. Some of our sites, I think 7 of our sites in the Itchen, were actually visited by boat, because Peter Taylor took us out to visit some otherwise inaccessible buoys and things like that we could collect off of in the Itchen. We then divided, for the sake of comparison, we divided each river into 8 zones, which were roughly of equal length within a river, obviously slightly shorter on average in the Itchen than in the Hamble, as Itchen being the shorter river. And in each of these, we have at least one data point, one site that we were able to survey, but typically more than one. Things got a bit sparse above the M27 in the Hamble, because there the river's running through more or less open countryside and access points are rather few and far between. So we scored each of a suite of 24 non-natives at each site that we visited in the summer of 2017. Okay, so we have data for 16 zones. In a zone, it may be that there's more than one data set from more than one shore or marina, or combination of both. And if so, the data was averaged out. So we did estimate abundance of species roughly as, rather few, or to 1 or 2, quite a lot, and tons. So in that kind of broad category. But we basically took an average for each zone based on either the one visit, in which case obviously not an average as such, or the multiple visits that we managed in that zone. And now we want to look at our data. So one way of displaying the data is with a kite diagram for each species in each river. And this shows just a selection of 10 species from the 24 we scored. And these are chosen just to illustrate the different sorts of species, sorts of distribution that we found. And in these kite diagrams, each species is marked with a thin line running right the way up the estuary. But where the species occurs, that line gets broader, proportional to the average abundance in that zone. So here, there's a very abundant species in zone 4, but it peters out to either side of that, becomes less abundant to either side of that. And where the line is minimal, the species is absent. So what did we find? Well, in the Itchen, the species are ordered roughly with their center of maximum abundance running up the screen from the seaward side, zone 1, to the freshwater end, zone 8. In the Hamble, the species are presented in the same order, but it doesn't look quite so progressive in that case, and we will identify why that is in a moment. So if we go through these types of species, then this is a species which is present in zone 1 and occupies fully marine sites as well, full salinity sites, but it peters out rapidly and is absent in zone 2. So this is a moss animal, which is basically a marine species that doesn't get very far into the estuary at all. And the same species does the same thing in the Hamble. A second category of species would be a species that inhabits the top of the estuary and may go into fresh water. The example shown here, a hydroid called Lophra caspia, is such a species. So it inhabits the very dilute seawater at the top of the estuary, but also goes into fresh water. And it's the same in both estuaries. These, a tube worm, a worm living in a calcareous, a calcified tube, and an acorn barnacle, are both truly estuarine species, which are pretty much dependent on some degree of seawater dilution, but they're tolerant of a broad range of dilution, so they extend literally or pretty much the whole length of the estuary in both rivers. Now, these are species which do occur in fully marine waters, so they are fully marine species, but they go up the estuary quite a way, longer than the moss animal I showed first. But there's a difference really between the Itchen and the Hamble in the extent to which they go up the total length of the estuary. So in the Itchen, these are actually two sea squirts, a colonial sea squirt and a unitary sea squirt, and they both go, shall we say, about a third of the way up the length of the estuary in the Itchen. But in the Hamble, they go a lot further up. So they're penetrating further distance-wise into the estuary as a proportion of total distance length of the estuary. And we'll try to maybe explain that later, that difference. There's actually a third example on here, which is a sea spider, which again goes quite a long way up the estuary, but goes further up the Hamble as a proportion of the total length of the estuary than in the Itchen. Okay, then there are some concrete differences between the two rivers in terms of the species that we detected. So this is another species of moss animal, and basically it was not found at all in the Itchen in 2017, but in the Hamble at the same time it went a long way up the estuary and could still be detected in low numbers quite near the top. Now in this case I want to offer an explanation at this point, because this is a relatively recent species arriving in the UK at all. We first found it in Plymouth in 2008, but we did detect it at low frequency in the Solent area in 2009. And since then, we found it in more and more sites in the Solent area, and it was an early entrant into the Hamble Estuary. Okay, so it's been in the Hamble for quite a long time, and it's gone a long way up. But we didn't see the species in the Itchen up until 2017 when these surveys were done. But we since have found it in Zone 1 in 2019, which was in Ocean Village near the mouth of the Itchen as a rare species. So effectively the absence of that species in the Itchen is because it hasn't colonized there yet. As a reasonably recently introduced species, it may well progress up the Itchen eventually, and it may be doing so already because our observation was 3 years ago. And so this essentially is not here because it hasn't reached the Itchen yet. Okay, another concrete difference, but in reverse this time, is a species that's in the Itchen and abundant there, but was not recorded in the Hamble. And this is the orange striped sea anemone, Digemini lineata. And I'll try to explain the situation with that one later when we've had a broader look at the data that we gathered for these two estuaries. So how are we to analyze these data? What data we have is for 24 species. We have we have whether they were recorded as present or absent in each of 16 zones, 8 zones per river. So that's a very big body of information if you think about it. And the analysis of this information is in a sort of arm of statistics known as multivariate statistics, which involves summarizing in some way the total of the resemblances between one zone and another, between all possible pairs of zones. So the resemblance is calculated, and there are various ways of displaying those overall resemblances, that complicated mesh work of resemblances in a reduced number of dimensions, essentially. And what we've done here is called multidimensional scaling, and this relates to the non-native species composition in 16 zones of the two estuaries in terms of the species present and their relative abundances. And what you can see is that these points, the underlying point about this is that if 2 points, 2 zones are displayed close together, they're similar. If they're far apart, they are dissimilar in their composition, the composition of their non-native species present. And you can see that on the long axis of the diagram, there's this progression, numerical progression from Itchen zone 1 to Itchen zone 8, and parallel to that, Hamble zone 1 to Hamble zone 8. So effectively, the progression of non-native species up the estuary is illustrated in the horizontal axis. That's those differences between upper estuary and lower estuary are spread out along the horizontal axis. But you also notice that the rivers are distinctly arrayed in one above the other. And so the differences in the composition between the rivers as a whole are on the vertical axis. So we have an axis which separates the two rivers, an axis which separates marine and freshwater ends of the estuary in the same manner for both rivers. You also notice that the first 5 zones for the Hamble are closely grouped. So they're very similar to each other. Not much is happening over those zones. And then things start to shift rapidly when you get to Hamble zone 6. In contrast, the Itchen is more evenly spread. It's more of an even progression from left to right, with the different zones relatively evenly spread. Also note that Itchen zone 1 is quite close to this cluster, this group of Hamble lower zones. A second multivariate analysis method, which is an alternative for looking at, for visualizing relationships between a whole set of localities like this, but which has the advantage that you can actually test the significance of the groupings, is to do a cluster analysis, as it's called, which employs an algorithm to join the zones, starting off with them all individually, to join them up sequentially into groups, into a series of clusters based on their respective similarities to each other. And if you do this, you end up with a diagram looking like this, a cluster plot of non-native species composition. Again, we're clustering the zones in the 2 rivers, and this is done by a particular algorithm. There are various to choose. This is by group means, and what we see is that this different technique has generated the same grouping that we saw in the MDS plot, so, which has Itchen 1 and Hamble 1 to 5, but that there are 2 other major groupings on the cluster plot, and these 3, this group, and this group, are all statistically significant groupings. So we have what is a series of low numbers. These are low in the estuary, near the mouth of the estuary. We have some middle numbers, H6 and I, 2, 3, 4, and 5. and we have some high numbers, H7 and 8, and I6, 7, and 8. So these can be named not with reference to any particular overall naming procedure for estuaries, but just from this analysis alone, lower, middle, and upper estuary groupings. Now, if we transpose those groupings back onto the two rivers separated out, illustrated separately, we get this picture with the Itchen and the Hamble side by side, zones 1 to 8, 1 marine, 8 up at the freshwater end. And so we see that in the Hamble, the lower estuarine grouping takes up more than half of the length of the estuary, whereas in the Itchen, it's just zone 1. So effectively, from a sort of a biota point of view, looking at non-natives, then zone 1 of the Itchen resembles zones 1 to 5 of the Hamble. So the Hamble has a much longer, if you like, marine end to the estuary, relatively speaking, relative to its total length, than the Itchen does. But the Itchen has this long transitional phase, the middle estuary, which takes up 4 zones, whereas the equivalent part of the Hamble, according to this analysis, is just zone 6. And then above that, we have the area of first mixing of freshwater and seawater. And so what explains this, or appears to explain this, is if we consider the amount of freshwater flow in the two rivers and compare that. So this is showing the average winter freshwater flow. In the Itchen, it's coming up to 12 cubic meters per second, but an order of magnitude basically lower in the Hamble, so much less freshwater flow in the Hamble, 1.3 meters cubed per second of fresh water on average in the winter. So this really explains why lower estuarine conditions pertain over a much greater proportional length of the Hamble than the Itchen, and to some extent why the middle zone is much relatively longer in the Itchen than the Hamble. This isn't a zone with a sort of intermediate level of mixture of freshwater and seawater. Now, this prolonged lower estuarine part explains why many of the species that are marine species extending into the estuary go further up the estuary than do in the Itchen. And also we can go back to thinking about the orange striped anemone, which, if you remember, we didn't find in the Hamble, but zones 5 to 2 are the zones in which the orange striped anemone thrives in the Itchen. And this would equate to zone 6 in the Hamble. And in zone 6 in the Hamble, we visited one site, which was Manor Farm Pontoon and the adjacent shores, and we didn't find the orange striped anemone. And that is the basis for us basically not having seen it in the estuary as a whole. So here we have zone 5 to 2, if you like, the middle part of the estuary, but the equivalent zone in the Hamble is here, but that is essentially one spot, probably not terribly suitable for the orange striped anemone, and we didn't find it there, and that's why that's blank. So it is possible that orange striped anemone does occur in the relevant section of the Hamble, but that we didn't look in the right place. Okay, so one final feature of the, particularly of the Itchen, which I wanted to bring out, is these very large populations of trumpet tube worm in the, over quite a large part of the estuary, but peaking around about zones 4 and 3. And this is a species which benefits from warm summers reproductively, apparently. And in August 2014, Rob Holland, who's an ex-MBA person, sent me these nice photographs of the boat owned by Oil Spill Response Limited, which is based on the Itchen, with the boat moored on the Itchen. And this incrustation of the hull and the propellers was really thick, several centimeters certainly, and this species can jam propellers if with very rapid growth, actually, if they're left unattended for a reasonably long period of time. And so this is very much a feature of the Itchen, this really kind of problematic incrustation by trumpet tube worm in the sort of middle part of the estuary. Okay, and with that, the second session has been completed.